Hello everyone. In this video I'm going to be talking about a statistical test known as Chi-Squared. I'm going to base this particular test around this rather dodgy looking picture that I've drawn over to the right hand side here. This is meant to be a picture of what's called a periwinkle, a snail found on rocky shores. And in biology, especially if you're doing field study and field work and you're looking at collecting data and performing statistical tests on it, the periwinkle is one that you can do a really nice chi-squared on. So I'm going to talk through how to do a chi-squared, the purpose of it, and use this snail as my example, as I've done in my other videos on standard deviation and Spearman's rank. So this will be my example here. Now, there are many applications of chi-squared, but they have the same underlying principle. Observed frequencies are compared with expected frequencies. So this is a test you use when measurements relate to the number of individuals in particular categories. So key thing to remember, chi-squared, it has categorical data and it looks at actual numbers of individuals in categories. And it's where you compare the observed number that you find with the number that you expect to find. And we're going to use this formula here. So chi, it has this bit like an X shape, chi squared, it's known as, is equal to the sum of, and in brackets we have O minus E squared over E. Now I'll explain what those numbers relate to just now. So we have the X squared symbol almost representing our chi value. O represents our observed result. And the E represents our expected result. So what we're going to do now, to save a little bit of time, I'm going to just put in here, save me writing all of this out, the very question that I ask my students to do with this snail. So it's a little bit cheating, but so I've just copied that straight in and we're going to work on this. So here's the scenario. I've put quadrats randomly along a rocky shore, and observed frequencies were generated by assigning each flat periwinkle that I found to a microhabitat category. So microhabitat is a smaller region of a habitat where an organism lives. Now, what I've done in this table is I've got habitat category down the side. So we've got serrated rack, bladder rack, egg rack, spiral rack, and just on other algae. So they're the types of seaweeds, if you like, that I've observed. And I'm counting, where it says observed frequency, I've counted how many flat periwinkles I found on each, or in each habitat. So for example, I've got 45 in serrated rack, I found 38 at bladder rack, and so on. Now, at the bottom, what I've done is put two questions that I ask my students to consider. So number one, a bar from Calculate Chi-Squared says, can we reject the null hypothesis with 95% certainty? Now, as I've said in my other statistics videos, a null hypothesis implies that there is, you just blankly say there is no link, no statistical link or connection between the two. So a null hypothesis in this would be that the flat periwinkles would be distributed completely evenly over the microhabitat types. So if this chi-squared is looking for, is there a preference or not, your null hypothesis would be there's not at all. They're completely even in their distribution. You wouldn't expect to see more or less in one place or another. So that's what our null hypothesis would be. So now we're going to work through this chi-squared. So we've got observed frequencies here, and there's a total of 100. Now, expected frequency, if this were a case where we could reject or accept null hypothesis and say that it's completely uniform, then in terms of expected frequency, we would think there would be 20 at each site. If you're expecting the 100 snails to distribute themselves evenly across the 5 different habitats, you would expect 20 in each one. So this is our E column. Next, you then do O minus E, so the observed minus expected. So this one here would be 20, this one here would be 18, minus 10, this would be minus 15, and finally at the bottom would have minus 18. So when you're doing a chi-squared, what you do is you make a table with the categories down one side, the observed frequencies next, the expected frequencies after that, so you have those three columns. Then you do the observe minus the expected result. Then we need a column O minus E squared, like we've got in the formula. So we're going to square all of these numbers. So 20 squared would come out as 400. 18 squared is 324. Minus 10 squared would come out at 100. 15 or minus 15 squared would be 225, and finally 324 again. So they are our O minus E squared values. And you see the last column is O minus E squared divided by E, the expected result. Now if we go back to the formula, chi-squared is the sum of all of those values. So ultimately we're going to be interested in this bottom box here. So let's work out the sum of all of those O minus E squared over E values. So O minus E squared for the top one, for the serrated rack, is 400, divided by E, which is 20, gives a total value of 20. And if we keep going, 324 divided by 20 would come out at 16.2. 100 divided by 5 would be 5. We have 11.25. And then finally, 324 divided by 4 divided by 20 is 16.2. And that would give a total, if we were to add up everything in this last column, a sum of, that would give a sum of 68.65. And that is our chi-squared value. So chi-squared is the sum of all the O minus E squared over E values that we've calculated. And so chi-squared is 68.65. Now, on its own, that doesn't mean a great deal. But what we have to do, like with Spearman's rank, is look at a table of critical values. Now, you'll be given in an exam a table of critical values, and it says, it has basically two columns, degrees of freedom and the critical value. The degrees of freedom represents how many categories we have. So in this we have 5 categories. So we'll just make a note here. I'm not going to include the table that you would be given, but I'll make the point that we have here a total of 5 categories. And the critical value, so the critical value at 5 categories, if you were to look up, would come out at 11.07. Now all we have to do is compare our value for chi-squared to the critical value, like you would do it with Spearman's rank. And if our critical value is higher, if the value is higher, then we can reject that null hypothesis with 95% certainty, because that's what we're looking at with this. When we look at the critical value, we look at the sort of 5% column. So we say that if our value is higher, is equal to, in fact, or greater than the critical value, then we reject the null hypothesis with 95% certainty. So that shows from this result, this snail result, quite clearly there is a significant difference between the observed and expected values. So these periwinkles, these snails, definitely have a preference as to where they live. I mean, you could see from the numbers, serrated and bladder wrack are well over 30, over 30s and 40s. spiral rack another, you've got 2, 5, even egg rack at 10, significantly lower. So you can see just from the results there seems to be some preference. If our critical value if our value rather were less than the critical value, then we would accept the null hypothesis and say that any difference we found is purely due to chance, and most likely that there really is no preference in that we perhaps could have seen those expected values. But because 68.65 in this example, our chi-squared value, is greater than the critical value of 11.07, we reject the null hypothesis with 95% certainty and say that there is a statistical significant difference there, that there is a notable change between the observed and expected values, and that there is a preference therefore. The second question that I ask my students to consider is the distribution of this flat periwinkle determined by microhabitat? And I think we can clearly see that the answer is yes, because clearly they do have a preference. So this, in a nutshell in this video, is chi-squared. It's a statistical test that is employed whenever you have data or measurements that relate to numbers of individuals in particular categories and where you can compare observed numbers with expected numbers. Okay, hope all that helps.